All right, so we're going to get into our first real exploration of the word problems when it comes to exponential growth and decay. And the first thing you really want to think about here is our basic two types of functions. You basically, for exponential growth versus exponential decay, you're going to be able to see a clear difference here. And this is where something is increasing in value, right? So that's one of the words you might see is increasing. Another word that you might see in the word problem is maybe a word like appreciating. So that doesn't mean to say, hey, I appreciate you, but appreciate is like typically what we hope our home values are doing. I own my home and I hope that it's appreciating in value. That means it's increasing in value versus exponential decay, some of the key words that you're going to see here are maybe it's decreasing in value, something is decreasing, right? Or maybe the opposite of appreciating is depreciating. So to depreciate, right, is when something decreases in value. A great example of this would be your car loan, or excuse me, the value of your car. Those things always depreciate in value for the most part. So these are some of the key words to look out for. Not the only words by any means, but definitely some of the things that you're trying to identify or point out in the word problem. We're going to start with exponential growth. So exponential growth has a very specific formula. So I want you to write the one we've been using for a few days now. Y equals A times the B value raised to your X. Now you'll notice that I didn't write the plus K. I'm not writing the plus K because honestly, in word problems, you rarely have a K value. The K value really doesn't play a role in in exponential growth and exponential decay word problems. Now, you'll also notice that over here on the left-hand side, we have a bunch of letters that aren't the same as what we've been using. They're different letters. So I want to show you where these letters are actually coming from. The y, that's still what we're used to. So we still have our y value. Nothing's changed there. So y equals. The a value we still have as well. There's nothing new with the a value. That part stays the same. But what's changing is the b value. Our b value takes on a whole new form. And we've kind of previewed this in some of our word problems a couple days ago, but it's basically going to take on the form, and this is always going to be this way 1, and then it's going to be plus, and this is coming from what we talked about on our comparing linear and exponential. It's going to be 1 plus r. Now it's 1 plus r because it's an addition problem. Because think about that. If you do 1 plus r, that's going to be greater than 1. Right? Your r value is going to add to the 1, which makes it greater. Now, one thing that I remember telling you guys earlier was that your r value, 99 times out of 100, your r value is going to be given in the form of a percentage. So that's where your percentage is going to get plugged in. But you've got to make sure you write that percentage as a decimal. So make sure that you're writing that percentage as a decimal. So you're not, if it says 3%, don't just put in a 3. You're going to put in a 0.03. We'll talk about that in a little bit. Last but not least, all of this whole function, this whole base, the r, the 1 plus r, is all being raised to the t power. And the only reason we're using t instead of x is because t stands for time. So let's write that in right now. Our t value stands for time. Now that might be years, it might be days, it might be hours, it can be a lot of different things, but your t value is your time value. We just talked about the r. The r value is your rate. Now your rate is always as a percentage, and we write it as a decimal. So your R value is your rate. And then your A value, we talked about this already. This is your starting amount. Your starting amount. So you're going to be given a starting point, right? You'll see here in a second that you're going to be given a starting point. And then the very beginning, actually, your Y is actually your answer. This is what we're trying to find. And your Y is your final amount. It's your final quantity, whatever that might be that we're looking for. That final piece. That'll typically be your answer. So we're going to look at some of these examples and we're going to do them in a two-part fashion. We're going to create the equation first, and then we're going to actually solve it by plugging in a value. So to write our equation, we essentially need to find these main components. We need to know our A value, we need to know our R value, and our T value. So let's try to start diving in here and see what we can find. It says in 1971, there were 294,105 females, so 294,105 girls participating in high school sports. Since then, that number has increased. That's a key word. Underline that, increased. The reason why we need to identify that is increased tells me to use addition right here. We're going to be using addition because of the fact that we said increased. And it's increasing 8.5% every year. So let's talk about this equation. Let's write down what we know. We know the A value and we know the R value. Our A value is the amount that we started with. So that's that 294,105. It says that we're starting out in 1971 with those 294,000 girls that are playing high school sports. Your R value is our percentage, 8.5%. But like we said, we're not going to write it as a percent. We're going to write it as a decimal. So if you want to convert that to a decimal, we need to simply move the decimal point over two places. So you become 0.085. So you can see that all I really did there was move my decimal point two places. So it was right here. We moved it once, twice. That creates your percentage as a decimal. All right, I've got the two pieces. Let's create our equation. So my equation is y equals my starting amount, A. So my starting amount was 294,105. Open parentheses. Remember, this is always going to be part of our equation. The 1 plus, it's only plus because of our increasing, plus the rate, which is 0.085. Close that parentheses, and it's all raised to the time t, or time t. So now that we've got that equation, now we need to create how do we actually answer the question? How do we figure out how many females participated in high school sports? How many girls were there playing sports in the year 2008? Well, you would be really, 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 really off if you took 2008 and you plugged it in for T. You can't do that. That's ridiculous. It's not been 2008 years. So what we need to do is we think of, okay, how much time has passed? How many years have passed? Well, we got to go back to, well, when did we start? Well, we started in 1971. So if you want to figure out what your T value is, you take the time that we have now, it's the time the year that we're looking for, 2008, and subtract out the time that we started. So 1971. All right, so if we subtract, all right, think about that if you want to do that in your head, 2008 minus 1971. Let's take away 1 first, that's 2007. So now 1970 to 2007, that's going to give me 37 years. Okay, so that's my actual T value. So to now actually calculate our amount, this is what we're plugging in the calculator. We're going to plug in 294,105, open parentheses, 1 plus 0.085, close parentheses, all raised to the 37th power. So that's what we're typing into our calculator. So let's do that together. Type that in your calculator, see what answer you get, and join me in just a moment on the next video.